Aloha, Rich Alverson here. This is ICS235, and in this video, I'm going to go over the important things in Chapter 1 and try to get you through the lab at the end of the chapter. So, we're starting out here. This is Section 1.1, and let me get myself out of the way. I'm going to have the important points on the right side here, and if you can read that, and then I'm going to have the textbook on the left side. So you should go through section 1, section 1.1, and it starts you very basic. It doesn't assume you really know anything. You're a second year, first or second year computer science student. You've probably had ICS 111 and 211, maybe, but just go through this, and really we're just going to learn about procedures. We're going to learn how to recognize the different types of models, and we're going to learn how to set up these scikit procedures, and you'll see what that means, to solve these problems. And so in this first section, section 1, you should learn and remember the difference between supervised models, and supervised models make predictions about some certain output that you're targeting. You're trying to predict if it's A or B or C, and you already know A, B, or C. There's unsupervised models, and that's where you're trying to figure out what the categories are. So you run an unsupervised model, and it's going to say, oh, this looks like an A, this looks like a B, looks like a C, and then it gives you you can see what the features are, which predict those. And then there's reinforcement models where you make a new decision based on an old decision. We're going to be using Python. The programming language is going to be Python, and don't let that scare you. We aren't even going to write any loops or conditionals or anything. So it's just statements, a series of statements to do a sequence of functions, and at the end you will be able to print out the output. The inputs will be the keyboard, and then the output will display. And so we're going to use this library called pandas, and you'll see how we bring in libraries for data frames, which is what these machine learning models use to represent data and to manipulate data. And then we're going to use this NumPy library for manipulating arrays. So that's what you learn out of section 1.1, and go through these participation activities and get the points. You can do the challenges at the end. You should click on these environments. These take a long time to load, but it's real easy to step through, and you can try things. And that takes you through section 1.1. And so section 1.2, here we learn feature and model types. We learn that there are categorical features and numerical features. And categorical features are a category, red, green, or blue, or the street they live on, or whatever. And numerical features, those are numbers, and those, numbers that you can add and subtract and multiply and so on. So these are both inputs and outputs. And for displaying data, for creating plots, we're going to be using MATLAB or Matplotlib library and Seaborn. Okay, so of the types of models we talked about in section 1.1. We go back up to section 1.1. Supervised, unsupervised, and reinforcement. There are the two kinds of supervised models, and that's where you know what output you're targeting. You're predicting an output. Classification models predict categories. The output is categorical. It's blue. It's red. It's it's a lion, it's a tiger, or the other kind of supervised model is regression model. Like we're going to try to predict the price of a stock or something. Predict the price of a stock tomorrow, for example. And so the output is numerical. All right, so that's what you should get out of section 1.2. And you should do the challenge activities. They're very simple, they're very straightforward. If you miss, that tells you what you did wrong, and it'll give you another chance. And it'll keep on giving you chances until you finally start seeing the same ones over again, and you should be able to get all the points eventually, but you should try to get all the points in the fewest number of points. There's the unsupervised models. This is for figuring out what what categories are. There's clustering models, which group instances with similar features. There's outlier detection models, which will identify outliers if you want to find something. If you want to find the oddball cases, for example. And then there's dimension reduction, where we might take two related features and combine them into one feature to make the model more simple. And then, of course, there's reinforcement models, which make decisions and update based on a result of a previous decision. So that's section 1.2. All right, section 1.3 is probably the most important section because it introduces you to the scikit-learn, which is what we're going to be using to learn about machine learning and do machine learning problems and so on. There's the scikit-learn has got a workflow, okay, and it's how it works. Okay, so first, it's a set of steps for loading, fitting, and evaluating a machine learning model. So first, you define the inputs and the outputs, and then you initialize the estimator. That's actually choosing the estimator in scikit-learn to do the machine learning that you're going to do, and there you're choosing. If it's, first you identify if it's a regression model you want, or a classification model, or a clustering model, and once you've identified what kind of model it is and the method, the modeling method, or the type of say supervised model based on the output, then you can pick the estimator, and picking the estimator is really what initializing an estimator is, because you got to know which one. And then you fit the estimator, and that involves training the estimator. You should have a massive amount of existing data where you have inputs and you have outputs, and that's real data, and you train the estimator based on this existing real data, and then after that, you can use that fitted estimator to make predictions. Okay, so you have this estimator; it's all trained with this older data, and then you can give it some new inputs and see what it predicts the output should be. And then you also at the end you want to evaluate the performance, and that'll give you a score on how accurate the prediction is. It'll either give you a score. This is for supervised models. So the score, if it's a classification model, the score will just be a number between 0 and 100. If it's a regression model, it'll be a percentage correlation, and of course the high one is the highest. The higher the better, and so on. All right, so that's 1.3, and so you go through these, click through these. I think I might have exposed you to some of this in the previous video, doing these things. First, you need to define the input and output features. Then you initialize the estimator. Then you fit the estimator. Then you make predictions. Go ahead and make predictions. Predict which stock is going to go up tomorrow, and then you evaluate. All right, and then that's how you get the points. All right, so that's 1.3. So here, let's try to do this Jupyter mod. Okay, so um, these are like 5 or 6 Jupyter models, and you'll see what they are. The first one just shows you the first step. No, yeah, with defining the first, it shows you the first step, which is defining the input-output features. And then the second one shows you the next step is to initialize the estimator. And then the third step is to fit the estimator. And then the fourth step is to make the predictions. And I think here is where I'm going to actually click on this. And so we can see actually, because this actually contains everything that was above it. So I'm going to click on this and wait till it opens up and show you how this works. Click. Okay, that usually takes you know 10 or 20 seconds, and so I stopped recording for a few seconds to shorten it up. Anyway, okay, so this is here we have this is the Python program which uses all of these NumPy and pandas and these plotting ones and so on. It has them all here, and this is a good example. Once you load this thing up, you want to click this double arrow thing, click that, and it sort of starts it back up again. And here we go. So the first thing we do is we import the NumPy library, and we're going to refer to the methods in that library by prefixing it with NP period. Same with pandas, PD period, and the plotting libraries here. And then we're going to bring in the scikit-learn. And for this one, we're going to do linear regression. Okay, so we're predicting some numbers based on some inputs. And I guess we're gonna predict the price of cab rides based on distance. So we're going to use distance to predict the price of a cab ride. Okay, so and for that we're going to use linear regression. That's the estimator model that we're going to use. So that's what that is. And so the first thing is we want to load the data set, and can we? I guess we can't see the data set, but it's got a distance column. It's in a nice array, two-dimensional array, where each row in the array is an instance. There's a whole bunch of them. Okay, and there's columns. There's a distance column, and there's a price column, and this is all old data. And that's what we're going to use. Okay, so here this initializes the model. We're going to call our model the linear model. This is a Python statement. And we're creating an instance of a class, I guess, a new object, and we're going to using this estimator. And then this is the step where we fit the model. And what we're doing is this is the input, this is the inputs, and this is the X. Yeah, this is the input and this is the output. And then this here just you just write this statement here. Should just this statement is what's displayed when this executes. Okay, it just is telling you what it did. And then here okay, so here we're just showing you a bunch of predictions for X, and this displays the output array. So these are the prices, I guess. And but anyway, this doesn't matter. Okay, here we have here we're going to test it with some data. We're going to predict the price of a cab ride when the distance is 2 miles. So this is input. This is we're inputting this. This is how you input a distance value here. And then here we're using the predict method on this input data, and this is the output. It says $15.89. Yes, that's what that is. Okay, so anyway, we're going to do something similar to this when we do our lab at the end. Okay, so that's what here. Oh, here we talk about evaluating estimators, and if it's a classification model, it's going to be an accuracy number between 0 and 1. And if it's a regression model, it's going to be an R-squared number, which is also between 0 and 1. Oh, but there can be negative R-squared numbers, I guess. All right. So, and this shows the estimate using the estimators, but we aren't going to have to do that for the lab. But you should go through all of these, okay? And then do these challenge activities. They're really very easy after you've gotten all this set in your head. All right. Now this fourth section, which is the last important section. Well, actually, all the sections are important, but this is for being able to do the labs and all the challenges and so on. You learn about this bias variance trade-off. And so that is, see what my notes are. Prediction. There's prediction errors, and there's there are, let's see, prediction errors. Oh, okay. Prediction errors are the difference between the predicted values and the observed values. And so, we said based on 2 miles, the cab ride was $15.89. And so that's a prediction. And what is the error? So the error would be you take the cab ride and they charge you, $17. And so the prediction error was, $2, the difference. There's a bias, and that's after you look at a bunch of predictions. Are the predictions biased to be more expensive than are the averages, biased to be more expensive, or is it, or is it biased, or is it not biased at all? If are all of the predictions as often as they are over, that's how often they are under. So it's like it's even. The error is evened out. And so that's the error variance. The variance is the average squared. That's a way of measuring a bunch of errors, where the farther away it is, the worse it is, and so on. This is this is the definition of that. You at this in 2025, we're doing this stuff, and you will never have to do these calculations. If we were learning this back in 1995, then we would be learning about how to do these variance calculations and so on. I taught statistics a long time ago, and that's what we had to do. But anyway, so lucky you just have to understand it, okay? And that's not as hard as doing it. All right. So there's this. So we have this error variance. We have this bias, and then we have this variance. Okay. So low variance. See, they're pretty close to. This is low bias and low variance. All the predictions are very close to being exactly what it was. If there's a high error variance, then sometimes the predictions are kind of off. But at least on the average, they're off just as much, over as under. If we have a high bias, it means it's going to be a whole bunch of them are going to be or it's going to be biased towards being too expensive or too high a prediction or too low a prediction. And if we have both high bias and error variance, then it's just kind of like spread out like that. So that's what this diagram is intended to show. And then we should also learn that, okay, so the polynomials, so this is for regression, because we have polynomials. And so one thing to know is that when the error variance decreases, no, no, okay, when the polynomial degree increases, that means that the equation for predicting is more sophisticated. It's got more terms. It's got some squares and cubes and 2 to the fourth power and fourth power, or so on, higher powers. That's the degree of the polynomial. As you increase the degree of the polynomial, the error variance decreases. Well, that kind of makes sense. It's getting more and more accurate. The errors are just not as the variance decreases. The prediction variance increases because you have to think about this, and it's going to be it's not instinctive in chapter 1, but we're going to be looking at this a lot over the next 6 weeks, and at the end, these things should be more instinctive for you. So the prediction variance increases when the polynomial degree increases. That means and then the model goes from being underfit to overfit. And you can go through, you have to read section 1.4 to really understand what that means, but you can kind of understand what it means. Being overfit means there's too many terms and it tries to match it too closely. But then when we start to predict in the future, or if we predict off the edges of the data, it becomes way off. For linear, this is just like a 1-degree polynomial. There's the fewest number of terms. It's underfit, which means it doesn't really follow any sort of trends or changes in the curve of the data. Whereas a good fit, sort of the best of both worlds. And so you would see a good fit that looks kind of like this, and this more closely matches the what the data really shows. All right, so go through this, go through the challenges. You don't have to look at it. You don't have to understand any of this ever. And then here's a nice graph, and after a while you'll learn what that is. You'll learn about here's some nice graphs to show you what all these mean. Decide what's over, greatest, which polynomial models have, which of the polynomial models has the greatest prediction variance. Well, greatest prediction variance increases when the polynomial degree increases. So that would be what are A, B, and C? Which has so this curvy one here is the polynomial with the highest degree. The curvy one. This is the lowest degree, this is the middle degree, and this is the high degree. See, so C is the high degree. So with high polynomial degree comes high prediction variance. So which has the highest prediction variance? I guess it would be C. And in this one, which model is likely to be underfitted? With underfitted, as the polynomial degree increases, the underfitting gets less and less, becomes overfit. So it would be a low degree polynomial, which would be this one. This is the lowest one. So that's the one that's likely the most underfit. So that would be B. And did I get it right? Yes, I did. All right. Okay, so that's those concepts. This is machine learning ethics. You should read this so you understand what people are talking about. I mean, this is all common sense stuff, but you should learn the terminology. What does it mean accountability? What does it mean transparency, and so on. So that's what this teaches you. Okay, let's do. This is a pretty good example. It really helps you understand the differences in these concepts. You're able to identify numerical and categorical features. You identify the inputs and the outputs of the model. You identify whether the model uses a supervised model or an uses supervised learning or unsupervised learning, whether the model is a classification model or a regression model or a clustering model. And then you also identify the potential ethical concerns. Okay, so go through that and get the points. All right, let's do this last thing here. Let's do the lab. All right.